Welcome, everyone. Let's get started. Today, we are exploring a critical intersection of MLOps and ethics, evaluating a model using responsible AI principles before we approve, register, and version it in our workspace. Let's dive in. Let's begin by defining responsible artificial intelligence. Responsible AI is a foundational approach to developing, assessing, and deploying AI systems safely, ethically, and with complete trust. When we implement model registration and versioning, we cannot rely on accuracy metrics alone. We must evaluate our models against 6 core principles: fairness, reliability and safety, privacy and security, inclusiveness, transparency, and accountability. Why is this mandatory? Because AI systems reflect the decisions of their creators, and without guidance, they can inadvertently cause harm, exhibit bias, or leak private data. By establishing our AI principles as a strict evaluation gate, we ensure that no model is registered or versioned in our enterprise environment unless it proves to be safe and equitable. This deep integration transforms ethical guidelines into enforceable engineering standards. Take a look at this flowchart, which illustrates the model versioning gateway. On the left, we see the 6 pillars of Microsoft's responsible AI standard flowing directly into our central evaluation hub. This evaluation acts as a strict checkpoint. If an experimental model passes the criteria across all 6 pillars, it follows the green path to be officially registered and versioned in the machine learning workspace. If it fails, perhaps by showing bias or a lack of reliability, it takes the red path and the version is rejected, sending the data scientists back to the drawing board to refine their work. To practically apply responsible AI, we do not just rely on good intentions. We use a structured lifecycle framework consisting of 4 distinct phases: govern, map, measure, and manage. The govern phase lays the policy foundation, while the map phase identifies and prioritizes the risks associated with the specific AI system. However, when we are focused on evaluating a model for registration, we zero in on the measure phase. Once risks are mapped, the measure phase systematically evaluates them using rigorously defined metrics. This is where we calculate the likelihood of harmful content generation or evaluate the effectiveness of safety mitigations. By embedding this measurement phase deeply into our MLOps pipeline, we generate the hard data needed to justify registering a new model version. Finally, the manage phase monitors the system post-deployment. This process flow maps out the responsible AI lifecycle and how it integrates with our model registry. We start at govern to establish our enterprise policies, moving into map to identify specific risks like data privacy. Notice how the measure phase is highlighted. This is our evaluation engine. The output of the measure phase feeds directly into the model registry decision gate. Only after the metrics are successfully evaluated is the model version approved, allowing it to progress to the final manage phase where it is monitored continuously in production. To execute the measure phase effectively, we must select the precise evaluation metrics that align with our responsible AI principles. Every experiment needs objective measures to reveal whether changes improve or degrade agent performance. Otherwise, you cannot distinguish true improvements from subjective preferences. Microsoft provides several categories of built-in evaluators. For quality, we use metrics like coherence and fluency. For safety, we deploy risk and safety evaluators that detect hate, unfairness, violence, and self-harm, ensuring we maintain user trust. A particularly vital metric for enterprise applications is groundedness. Groundedness verifies that the model's responses are strictly based on authoritative source data, completely preventing hallucinations. If a new model version scores poorly on groundedness or triggers a content safety alert, the registration process is halted immediately. This block diagram breaks down the taxonomy of our AI evaluation metrics. From the top, we branch into 3 main categories: quality, RAG and accuracy, and risk and safety. Under quality, we measure coherence and fluency. Under RAG, we measure groundedness and relevance to stop hallucinations. Under risk, we actively scan for hate, unfairness, and violence. All of these specific tests funnel down into a unified model scorecard. This scorecard is the ultimate, objective source of truth we review before deciding to officially version and register the model. Understanding the metrics is step 1, running them at enterprise scale is step 2. We cannot manually read thousands of model responses to check for fairness or safety. Instead, we automate responsible AI checks using the Azure AI Evaluation SDK. Automated evaluations complement human judgment by running consistent checks across thousands of scenarios in mere minutes, enabling quick, confident decisions about deploying model changes. Using Python, developers can import specific tools like the Protected Material Evaluator or the Indirect Attack Evaluator. By leveraging the Evaluate API, you can run multiple evaluators simultaneously over a comprehensive test dataset formatted as SAML. This batch processing calculates an aggregate defect rate, giving you a mathematically sound validation of your model's safety and quality before you ever click Register Version. Let's walk through the automation sequence. The data scientist initiates the process by submitting their candidate model and a comprehensive SAL test dataset to the Azure AI Evaluation SDK. The SDK programmatically invokes the Evaluate API, triggering our suite of RI evaluators. The evaluators process the batch and return aggregate safety and quality scores. After reviewing these results, the data scientist can confidently register the new version in the model registry, knowing the decision is backed by rigorous, automated safety data. To guarantee that our responsible AI standards are never bypassed, we must integrate these evaluations directly into our continuous integration and continuous deployment, or CI/CD, pipelines. We utilize GitHub Actions to mechanically enforce our safety tests. When a data scientist updates a model and opens a pull request, the GitHub action automatically triggers. It securely authenticates to Azure, spins up the environment, and runs the Python evaluation scripts we just discussed. Why is this essential? Because pull request workflows automate quality checks before changes merge, physically preventing safety regressions from reaching production. If the automated pipeline detects that the new model version hallucinates more often, or fails a fairness check, the action posts the metrics, fails the status check, and completely blocks the model from being registered. Here we see the CI/CD quality gate in action. The workflow begins on the left when a developer opens a pull request proposing a model update. This event instantly triggers GitHub Actions, which runs our Python RAI evaluations. We then reach the critical decision diamond. Is the evaluation threshold met? If the model passes our strict safety and fairness scores, it takes the yes path, the PR merges, and the model is registered. If it fails, it takes the no path, the merge is hard blocked, and the team is alerted. A critical component of responsible AI is security, which requires us to proactively attack our own models before we version them. This is known as adversarial testing or red teaming. During the map and measure phases, we simulate adversarial or misuse scenarios to expose vulnerabilities. Standard evaluations might prove your model is accurate and fair, but adversarial testing proves it is secure against bad actors. We feed the model malicious inputs like indirect prompt injections or deliberate jailbreak attempts to see if we can force it to leak protected information or override its safety instructions. To do this effectively, we mix automatically generated adversarial datasets with manually created edge cases, relying on domain expertise to test highly specific, realistic vulnerabilities. Only models that gracefully deflect these attacks are deemed worthy of registration. This flowchart visualizes the adversarial testing process. We start with an adversarial test dataset specifically designed to break the rules. We generate malicious prompts and feed them into the candidate model. If the model fails by leaking data or following the malicious instruction, a vulnerability is logged and the model version is rejected. However, if the model successfully blocks the prompt, proving the mitigation is effective, it passes the security check and proceeds toward official registration. While we rely heavily on automation for scale, we must remember a vital truth. Automated evaluations complement human judgment. They do not replace it. Humans establish the quality and ethical standards, and automation simply applies those standards consistently across thousands of examples. Therefore, we must continuously align our automated evaluators with human criteria. If an automated script begins to drift from human expectations, we risk registering a model that looks mathematically perfect but is practically or ethically flawed. We solve this by conducting shadow rating, where human experts manually review a sample of responses and perform correlation analysis against the automated scores. This is an iterative process. As your domain evolves, you must adjust the scoring logic, refine keyword matching, and rerun shadow ratings to guarantee that your automated MLOps gates genuinely represent human values. Look at this alignment loop. The model output is scored simultaneously by the automated SDK and a human expert. Both scores feed into a correlation analysis diamond. If there is high agreement, we trust the automated evaluator and proceed. If there is a disagreement, we take the bottom path to refine the scoring logic, tweaking the automated system until it reliably mirrors the human expert's judgment. This calibration ensures our registration gates remain trustworthy. Let's tie all these concepts together with a critical real-world scenario. Prosware is a healthcare startup that has developed a diabetes classification and support agent for medical practitioners. In the medical field, the stakes are incredibly high. The model must not only be accurate, but it must be completely grounded in factual medical data to prevent dangerous hallucinations, and it must be stringently evaluated for demographic fairness so patient care is equitable. As the data science team iterates, they track their experiments using MFlow. However, before any candidate model is officially registered for production deployment, it faces our responsible AI quality gates. Using the Azure AI Evaluation SDK and the Responsible AI dashboard, the pipeline automatically measures fairness, safety, and groundedness. Only when the GitHub Actions workflow confirms that the new model exceeds all ethical and safety thresholds is the version officially registered and deployed to help patients. In our final diagram, we see the Prosware deployment flow. The candidate medical model triggers the GitHub Action CI/CD pipeline. This runs the RAI SDK evaluation, which simultaneously measures demographic equity for fairness and fact validation for groundedness. All metrics converge at the decision gate. Because the model passes all ethical and factual standards, it is officially registered as version 2.0 and securely deployed to the practitioner application, providing safe, reliable healthcare insights.
Welcome to quicktechie.com. So just type in quicktechie.com here. Then you can go through the material which is provided by quicktechie. So we have first of all video courses which you can go here and you can find the various video courses across the technologies as well as finance domain. So if you see in Microsoft, we have 8 programs currently running. Next, you can go through the ebooks available. So all the ebooks which are in PDF format today, and you can download this. So let me go through Microsoft certification ebooks. You can click on any of this and you can see this is the PDF available for you to download. So these are the premium ebook mostly available on quicktechie.com platform only. Now the second part is exam simulator. As we primarily focus on the all technology companies and finance domain certification preparation material. So this is company wide listed here and you can go through this. So let me go through the Microsoft one again. You can see these are all Microsoft related certification. AB 730 exam, if you open it, so you can see here this, and all the practice papers are available here. Today we have a 5 practice paper. So click on the first practice paper. It would load the questions. You can answer this question. This is way you can answer it and you can move to the next question. Now the third material we wanted to highlight is an audiobook. So we started recently with the audiobooks as well, which you can listen on the go, and various technology wise ebooks are available. And at the last, this is our alumni. These people who are subscribing to our courses and this platform, they are all listed here. And at the end, I wanted to tell you, if you find any course or training or certification preparation material which you want to get us prepared for yourself, please put on the comment section. If you're watching on YouTube, on Udemy, or on this platform itself, quicktechie.com, then please put the comment, or you can even send an email to using this contact us options here. You can directly do the WhatsApp message. You can call us on this numbers as well.